So we are starting with variable valency. Okay. First, you tell me valency of a particular element is equal to what? In terms of electron, you tell me.
Number of electrons is
Number of
gained.
electrons gained or lost to
Correct.
achieve stability of the nearest noble gas.
So number of electrons. Okay, mute. So valency with respect to electron is the number of electrons lost or gained. From where?
From the
From
valence
the
shell.
outermost.
From the last shell.
Correct. From the valence shell, from the last shell. So the number of electrons gained or the number of electrons lost from the valence shell of an atom, so that to attain the stable electronic configuration of the nearest noble gas, that is the meaning of the term valency. Okay. Now, in certain elements, you will observe the valence, the last but one shell. Imagine there an atom with three shells. Like K, L, M. Okay. So now M shell is the last shell, correct? The last but one shell is called what? Penultimate shell. Okay. For certain elements, the penultimate shell is unstable. So one or more electrons from the penultimate shell will jump to the valence shell. So what happens? The electrons present in the outermost shell will vary. Okay. So because of this, the element will show variable valency. So last year also you learnt example of metal copper, correct? Copper metal having atomic number 29. So electronic configuration is 2, 8, 18, 1. So 29. So what happens in case of copper? Because the penultimate shell is unstable, one electron from the penultimate shell will jump to the valence shell. So copper can show both the configurations 2, 8, 18, 1 or 2, 8, 17, 2. In such case, if copper atom loses one electron, it will form an ion with a charge of +1. If copper atom loses two electron, it will form an ion with charge +2. So this results in what? Variable valency. Here you can see copper is showing variable valency of 1 or 2. Correct? So an atom sometime can lose electron than present in the valence shell. From which shell is it losing electron? It is losing electron from
Penultimate shell.
from the last but one shell, which is the penultimate shell. So because in case of copper, one electron from the penultimate shell is jumping to the valence shell, so configuration is changing to 2, 8, 17, 2. So that is why copper exhibits valency of what? Valency of +1 and +2. Okay. If any element has to exhibit variable valency, which shell should be unstable?
The penultimate shell.
Penultimate
Penultimate
shell.
shell.
So penultimate shell has not attained stability in such elements. Okay, that is why electrons keep jumping to the valence shell. So in that case, these elements will show variable valency. So last year you learnt one table, variable valency table. Okay, let us try to recall that. You can write this in your book. Okay, variable valency. So which elements show variable valency? What are those variable valency?
Copper,
Yeah, we will write
Copper,
it.
iron,
Lead.
Yes,
Excuse me, ma'am.
yes.
gold.
Ma'am, there are a couple of students who want to join, ma'am.
Okay, I'm admitting.
Yes.
If they join on time, there is no issue. If they're joining in between, I have to go back again, check. Okay, anyhow, thank you. You told me. Okay, shall we start? See,
yes, ma'am.
generally variable valency is C naught +1 plus 2 plus 3 plus 4. Okay. So let us see which elements show variable valency of 1 and 2 or 1 and 3, 2 and 4 like that. Let us check. First thing you learned now, copper. So copper element shows variable valency of plus 1 and plus 2. Okay. Last year also you learned, children, this chart. Copper, what is Ag? Silver, then Hg.
Mercury.
Mercury. So these three elements show variable valency of what? Plus 1 and plus 2. That is why I have written it under plus 1 and plus 2. Got it? Are you also writing? Please write. Okay?
Yes, ma'am.
Yes, ma'am.
You learnt nomenclature last year. Do you remember, children, how to name these ions?
Yes, ma'am.
Yes, ma'am.
Okay. For example, Cu plus 1 ion. Correct? This is nothing but according to new system of naming. What do we write? Element name is copper. Valency we write in Roman number in the bracket. Correct? Then according to old system of naming,
Cuprous.
ion is called as what? Cuprous ion. And copper, according
Cupric.
to naming, this is just copper 2 ion. This is also known as what? Cupric ion. Okay. What is the hint here? The lower valency name should end with OUS. Higher valency name should end with IC. For example, last year also you named a few compounds. Imagine you have these two compounds, CuCl and CuCl2. What is the valency of copper in CuCl?
1 plus.
1 plus.
Because chlorine is
Plus
1 minus, copper is 1 plus. What is the valency of copper here? Plus 2. Chlorine valency is minus 1. So how do we name this compound? According to new system, IUPAC system of naming.
Copper what chloride?
IUPAC name. Copper in the bracket, what is the valency? Plus
Roman
1.
number
Valency is
1.
written in Roman number enclosed in the bracket. So non-metal is chlorine, name should end as chloride. So according to IUPAC system or new system of naming, the name for a compound CuCl is copper 1 chloride. According to old system of naming, Cu plus 1 ion, lower valency ion name should end with OUS. So what is the name of CuCl according to old system of naming?
Cuprous chloride.
Chloride.
Okay. Now, what about this? According to IUPAC system of naming, CuCl2 is nothing but copper
2 chloride.
chloride. According to old system of naming, how do we name CuCl2?
Cupric chloride.
Yeah, cupric chloride. So cuprous ion means Cu1 plus ion. Cupric ion means Cu2 plus ion. So copper shows variable valency of what? Plus 1 and plus 2. Similarly, silver also shows variable valency of plus 1 and plus 2. So according to old system of naming, Ag1 plus ion, what is it called? Argentus. Because lower valency name should end with what? Look here, lower valency name should end with OUS. So Argentus, argentic, or silver 1. This is silver 2. Similarly, mercury 1 ion. What is it called? Mercurous. Mercury 2, mercuric. Okay? Followed?
Yes, ma'am.
But
Okay.
ma'am,
Yes.
Latin name is hydragynum. How come we use like mercurous and mercury?
That is an exception in case of mercury. We don't call it as hydragyrus, hydragyric. It is simply named as mercury, mercurous, mercuric. Whereas if you see for copper, cuprous, silver, like argentus, mercury, the mercury is used just mercurous, mercuric. Gold, we use Latin name aurum. Mercury is the exception, you should remember. Okay.
Okay, ma'am. Thank you, ma'am.
Okay. Moving on to the next element. Which element will exhibit variable valency of 1 and 3? Let us finish
Gold.
1. Gold.
Gold.
Gold exhibit variable valency of 1 and 3. That is why I have written under the column 1 and 3. Okay. So gold 1, aurous. Gold 3, that is auric. Okay. Now moving on to the next element which exhibit variable valency of 2 and 3.
Iron.
Iron, very good. Iron, Fe. So Fe2 plus, Fe3 plus. What is Fe2 plus ion called?
Ferrous.
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 Ferrous. Fe3 plus ion is
Ferric.
called ferric.
Ferric.
Ferrous, ferric. Okay. Shall I make it small so that heading you will be able to see?
Excuse me, ma'am. Ma'am.
Yes. Somebody is waiting.
No, ma'am. What is the IUPAC name of code?
Aurum.
No, ma'am. IUPAC, writing Roman numerals.
Gold one. In IUPAC name, new system of naming, we just use their English name like gold only.
Okay.
Okay. Like how we use iron 2 chloride, iron 3 chloride, or iron 2 oxide, iron 3 oxide.
Okay, ma'am.
What is this? Some name it is showing?
Ma'am,
Saujanya.
it's Subecha.
Okay. We'll continue. See, in IUPAC name, this is just copper 1, copper 2. Similarly, what is Ag? Silver. Silver 1, silver 2. Mercury 1, mercury 2. Okay. Gold
Okay.
1, gold 3. Iron 2, iron 3. Okay. There are certain elements which exhibit variable valency of 2 and 4. Which all did you learn? Tin, lead, tin. What is the symbol for tin? Sn.
SN.
Lead is Pb.
PB.
Then you learned
Manganese.
You remember Mn. So tin shows variable valency of +2 and +4. Lead also shows variable valency of +2 and +4. So Pb2 plus, Pb4 plus. Then manganese also shows variable valency of +2 and +4. So Mn2 plus ion, Mn4 plus ion. Mn is a symbol for element manganese. But in old system of naming, how do we name? Manganese, manganic. Okay. Plumbus, plumbic. Sn is a symbol for
Tin.
Tannum.
tin, correct. But Latin name is stannum. So stannus, stannic. Okay, going forward, more you will be using new system of naming only than old system of naming. Okay. There is
Ma'am, is there
another
any other
element
element?
which shows, tell me.
Platinum.
Talking. Platinum, correct. Platinum also shows variable valency of +2 and +4. Okay. So platinus, platinic. So in IUPAC name, just you will write the name of the ion as platinum 2, valency 2 in the bracket in Roman number, and valency 4 in the bracket for Pb plus 4 ion.
Ma'am, does phosphorus also show variable
I will
valency?
come. Till now, I was discussing about metals. Yesterday also I told non-metals like phosphorus, sulfur also exhibit variable valency. Correct? So that we will discuss. So last year also, if you look at the valency chart in 8th standard book, you learnt under language of chemistry, metal like non-metal phosphorus was given valency 3 and 5. How is that? For example, see, phosphorus can form bond even with non-metals. Phosphorus will form bond with chlorine. For example, it can form phosphorus trichloride, phosphorus pentachloride. So these elements can also. So what is this? This is also known as oxidation number. You will learn in this chapter how to find out valency of a particular element in a given compound. For example, for PCl3, I will solve, children. We are finding valency of phosphorus. I don't know. I'm taking it as X, like your linear equation. There are 3 chlorine atoms. What is the valency of each chlorine atom? Each chlorine atom shows a valency of -1. So sum should be equal to 0. So x minus 3 is equal to 0. What is the valency here? X is plus 3. So when you go to college in detail, you will learn. This is also known as oxidation number. In simple term, this is the valency of a particular element shown in a compound. Okay.
Ma'am, is there any other element
Similarly, in
that shows?
PCl5, the valency of phosphorus is 5. Okay. Like that, element sulfur also exhibit variable valency of 4 and 6. We don't use these valencies much. Is that fine?
Yes, ma'am.
Okay.
Yes, ma'am.
Now, moving on to, see, group of atoms also exhibit some valency. Correct? What is it called? What is it called? If there is, for example, CO3 2 minus, what is it?
Radicals.
Radical.
Very good, very good, very good. So, what is the difference between these two? Already you answered now.
O2 minus is an ion, CO3 2 minus is a radical.
Radical. Okay. So,
Ma'am,
radical.
radicals are a group of atoms which act as one unit, but ion is just one unit.
Ah, so group of atoms which behave like a single unit and they show some valency. These are called radicals. But in certain textbooks, you can see even for radicals, generally they give ion. For the definition of ion, last year in your book, they gave it can be an atom or group of atom having a positive or negative charge. But when you go to higher classes, more in detail, when you will study ion can be an atom having a charge. Ion can be positive, ion can be negative. Correct? Positively charged ion is a cation, negatively charged ion is an anion. But what is a radical? Radical are group of atoms. So you can see there is one carbon atom bonded to three oxygen atom. They behave like a single unit and show valency. How do you know they behave like a single unit? For example, calcium carbonate. When calcium carbonate. So how is calcium carbonate formed? It has two things, which is that calcium ion, which is Ca2 plus. So when it splits up, it will split up to give calcium ion and it will split up to give carbonate radical. So this goes together. So or else one more, potassium hydroxide. When it dissociates, how does it dissociate? It will dissociate to give K plus ion. Is somebody, you're on unmute, children. There is some background noise. So potassium hydroxide, when it dissociates, you can see it will break down to give potassium ion, which is K plus, and hydroxide ion, correct? So which is OH minus. So OH minus is a radical. The reason is it will go together and it will exhibit a single valency. So radical are group of atoms. They behave like a single unit and they show some valency. You understood the meaning of radical?
Yes, ma'am.
Okay.
Yes, ma'am.
So even radicals can be of two types, correct? Radicals containing positive charge, positive radical, radicals having negative charge are negative radical, correct? We don't say ion now, positive radical, negative radical. Okay. So in your syllabus last year also you learned the only one positive radical. Can you recall which is that?
Ammonium.
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 NH4 plus.
So ammonium ion, which is nothing but NH4 plus. Somebody very difficult to remember. I used to tell them ammonia is NH3 plus H plus. Combine everything. How many nitrogen? One nitrogen. How many hydrogen? Four hydrogen together with a positive charge. So what is this ion? Ammonium ion, ammonium radical. Okay. It is also called as ion. It's fine. Ammonium radical. Is it clear?
Yes, ma'am.
Okay.
Yes,
So
ma'am.
let us write certain examples for negative radicals. Already I wrote one example, carbonate, hydroxide, correct, nitrate, you have learned,
Sulfate.
bisulfate, sulfate, all
Dichromate.
bicarbonate.
Sulfide.
All the sulfide is an ion. Sulfide is just a what? Anion. It is not a radical. Sulfide can be a negatively charged radical.
Ma'am, thiosulfate.
Mm.
Dichromate.
Dichromate, all those are examples for negative radicals. So radicals one by one in detail we will discuss. Okay. So this we discussed. Go through these. Then I'll continue. What is variable valency?
Ma'am, can we write this in our notebook?
Yeah, you can write. You want to copy? If they ask you define variable valency or explain the term variable valency, just you will write certain elements exhibit more than one valency. That is called variable valency. If they ask a reason for variable valency, then you write an atom can sometimes lose electron from the shell other than valence shell, which is the penultimate shell. This results in variable valency. You want to copy? You copy. Quickly, I'll wait.
Ma'am, so if they ask it like for like 1 mark, so we just have to write certain elements exhibit more than one valency. Like, ma'am?
Yes.
Ma'am, it is there in the book, right?
It is there in the book. Once you receive the book, you will get to know it is there in the book. Even it was there. If you have your 8th standard textbook, it is there in your 8th standard textbook.
Ma'am, it is there.
Yeah, it is there. Even valency chart is there. Whichever is new, that I will tell you to mark also. Okay.
Okay, ma'am.
If you have your 8th standard book, keep your 8th standard book with you whenever this chapter we are learning, because you're ready to receive 9th standard book. No, you can refer 8th standard book.
Ma'am, when are they gonna give the books? Ma'am, when are they gonna give books?
They told it will come in like 1 to 2 days. Mostly we'll check tomorrow.
Okay, ma'am.
I think this time the book has been revised. That is why it has got delayed.
Ma'am, penultimate shell means second last shell, right?
Last but one shell. Second last. The shell which is immediate to the last shell. Okay. Shall I go to the next slide?
Ma'am, 1 minute.
This already you have written a table. No need to copy this. Okay, don't copy. Now what is a radical? Go through. So positively charged radical are also known as basic radicals. Negatively charged radicals are also known as acidic radicals or acid radicals. It was there in your 7th standard. Do you remember, children?
Excuse me, ma'am.
First time when you learned
Yes, ma'am.
radical,
ma'am.
basic radical, acid radical, all those were there in your grade 7 as well.
Excuse me, ma'am.
Yes.
Ma'am, is NH for 4 plus the only example for basic radicals?
Yeah, in your syllabus only you have NH4 plus.
Okay.
Shall I continue? Next slide. Shall I go to the next slide?
Yes, ma'am.
No, ma'am, I'm coughing.
You're
Copying.
copying. Okay. Quickly write.
Yes, ma'am.
After this, we'll discuss the valency chart, children. Okay. See, I have taken a picture to show you what is there in the textbook. Okay, so that it is easy for you also to understand. Or else, if I keep on writing and going, you will think, where is it? Okay, so we will start with the valency chart. Under valency chart, valency of +1. Yeah.
Can you hide that thing in the bottom? Meet.google.com is sharing this.
Yeah. Okay.
Thank you, ma'am.
Fine. Huh? So I'm
Yes, ma'am.
starting with positive valency. So
Should we write this?
valency of +1 I'm discussing. Children, yesterday when whatever was covered, we will have a quick recap. For the new one, we will be spending more time. Okay. Yesterday, when we learned valencies of first 20 elements, you have learned hydrogen can show valency of +1, correct? Which is nothing but H plus ion, simply nothing but a proton. Then you have learned lithium, atomic number 3, electronic configuration 2,1. So lithium can also show valency of +1. What is the ion called as? Just lithium ion. Okay. Then sodium, atomic number 11, electronic configuration 281. So sodium also shows valency of +1. Then potassium, atomic number 19. Electronic configuration 28. What? After 28? 9, huh?
2881.
Very good. So it is 2881. That is the electronic configuration of potassium. So potassium also has a tendency to lose one electron. So potassium can also show valency of +1. Just now I discussed ammonium radical, the only positive radical which is there in your syllabus, which is NH4 plus. So all these are examples for valency of +1. Got it?
Yes, ma'am. Ma'am, are there any more positive radicals?
Which one? No, only this. Others and all, see in the lab, ammonium hydroxide is a weak alkali, okay? Other alkalis are all alkalis of metal hydroxides only, like potassium hydroxide, sodium hydroxide, magnesium hydroxide. So they're all just ions, not a radical. Okay?
Yes, ma'am.
Okay. Now moving on to valency of -1. Did you write at least? Please write, okay? You write in your book valency +1 or positive valency. Under that you write potassium K plus. Should I write in that whiteboard or you wrote? See, note down so that at home you can revise again, okay? So positive valency, okay? So valency +1. Under that, which all did you learn? Hydrogen, which is H plus. Then second one, lithium. Are you writing? Li plus. Third one, sodium, which is Na plus.
That we learned yesterday, right now.
Yeah. No, we will just write it together. So when you're studying, you study them together. It becomes easy. Okay.
Okay.
Then fifth one, you don't have textbook also, no? That is why I'm making you write ammonium, which is a radical, which is NH4 plus. See, whatever ions or radicals I'm teaching you today, please learn them on the same day, because going further you should be in a position to write formulas. For that you should know the what ion or radical, the formula with charge you should know correctly. Did you finish valency +1?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, then we will start with, so valency +1 can also be called what? Monovalent, correct? Let it be +1 or -1. Valency of 1 means monovalent, correct? So these are all monovalent examples for valency 1. Okay, now valency -1. For this, children, you have your old textbook at least with you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Do you know group 17 elements? Group 17 elements. Below hydrogen, there is
Yes, ma'am.
fluorine,
Yes, ma'am. Yes,
chlorine,
ma'am. Yes, ma'am. Yeah,
bromine,
they are
iodine.
noble.
Hey, not noble gases. Group 18 is noble gases like helium,
And fluorine, chlorine, and all. Ma'am.
Okay.
argon.
Yes, ma'am. Yes, ma'am.
Ma'am, halides.
I am talking about group 17 now. Okay.
And
Not,
hydrogen, fluorine, chlorine, and all.
so if you see in group 1, period 1, there was hydrogen here also. There was hydrogen here also. So valency -1, hydrogen. The ion is what? H minus. What is the name of the ion? Tell me. Yesterday's class I've taught you. H minus ion is called
Hydride.
Hydride.
what?
Hydride.
Hydride. Non-metallic name should end with IDE. Now, which is the next element? Fluorine. So,
Fluoride.
the ion is H minus. So, name of the ion is? How do you name?
Fluoride.
Fluoride. Okay, now chlorine. Are you writing? Please write, okay? So chlorine, chloride, okay? Next, bromine. All group 17 elements, they generally have 7 electrons in the valence shell, like fluorine, chlorine, bromine, iodine. They all have a tendency to gain 1 electron. So they all show valency of 1 minus, okay? Iodine, I minus, iodide. Please write. So look here. These are all elements of group 1. Am I correct? In your periodic table, first column.
Yes, ma'am. Yes.
Hydrogen is there,
Hydrogen, lithium,
lithium,
sodium,
sodium, potassium. So all have tendency to lose 1 electron. So valency is +1. These are all group 17 elements having 7 electrons in the valence shell. Leave this. Okay, so they have tendency to gain 1 electron. So valency is -1. Okay.
Yes, ma'am.
Yes, ma'am.
Now moving on to still valency. Shall I scroll down? Did you finish writing?
Yes, ma'am.
Yes, ma'am.
Okay. What is that pop-up? Somebody is joining now. Huh? Afan, raised hand. For what, Afan?
ma'am. So, ma'am, hydrogen is like in the first group, right, ma'am? Period 1 and group 1, right, ma'am?
Period 1, group 17.
But why group 17, ma'am? Because it has only like all the group 17 members are like chlorine has 7 atoms in the
7
valence shell.
7 electrons in the valence.
7
Okay.
electrons.
I understood. Listen now. Okay. See, group 17 elements are non-metals. Okay. Hydrogen is also placed with them. The reason is it also has tendency to gain 1 electron to attain nearest noble gas, that is helium configuration. So all other elements in that group, they have 7 electrons. They also have tendency to gain 1 electron to attain their nearest noble gas configuration. That is why position of hydrogen is also given there. Still the position of hydrogen in your periodic table is uncertain. It is not fixed. Understood?
Okay, ma'am.
Okay. Now moving on to some other radicals. First I'll teach what you learned last year. You have learned hydroxide, correct? For example, H2O. Water molecule, when it breaks down, it will give you what? H plus ion, and it will give you OH minus ion. H plus is nothing but a proton, hydrogen ion, correct? OH minus, what is OH minus ion? Hydroxide ion, correct? So OH minus is nothing but hydroxide. So what is the valency? Valency is -1. Are you writing here? Right. Hydroxide, OH minus. So it is an ion or it's a radical? It's a radical, correct? Oxygen and hydrogen together having a charge. For example, metal hydroxides, potassium hydroxide, magnesium hydroxide, sodium hydroxide. Okay. So what is OH minus there? Hydroxide. Valency is -1. Next, you have learned nitrate last year, and even under the chapter, I think chemical reactions, you have learned nitrate. Potassium nitrate on heating decomposes to give potassium nitrite and oxygen. Are you able to recollect?
Yes, ma'am.
Yes, ma'am.
Nitrate, NO3 1 minus. This is called nitrate. Nitrite, see ATE and ITE, some hint, trick to remember. ATE and ITE, they differ by one oxygen atom. Remove one oxygen atom. So nitrite formula is NO2 1 minus. I'm writing in some order so that it is easy for you to remember. I'm not following the textbook order, okay? But I'm like valency minus 1 I'm discussing, but I'm discussing in an order which will be easy for you to recall. So please copy. So nitrate is NO3 1 minus, nitrite is NO2 1 minus. Last year this equation you learned under thermal decomposition of metal nitrates. Potassium or sodium nitrate on heating will decompose to respective metal nitride. During this reaction, oxygen gas is avoided. Did you recollect that?
Yes, ma'am.
Okay. So nitrate, NO3 1 minus, nitrite, NO2 1 minus. So you have to just reduce one oxygen, but charge remains the same. Okay. Now children, there are lot of radicals like carbonate, bicarbonate, sulfate, bisulfate, right? So to make bicarbonate easy, first I'm writing few with valency 2 here. Okay. Carbonate radical. CO3 2 minus is carbonate. Under valency minus 1, you have something called bicarbonate, or it can also be, instead of bi, you can also name it as hydrogen carbonate. Instead of bi, you can even write as hydrogen. So what is this bicarbonate or hydrogen carbonate? See, carbonate is what? CO3 group having 2 negative charge. Bi refers to hydrogen. H is H plus here. I'm just removing one positive and negative sign. So what is left now? What is this? Read.
Bicarbonate.
HCO3 minus.
HCO3 1 minus. So HCO3 1 minus. This is nothing but bicarbonate. Got it?
Yes, ma'am.
Yes, ma'am.
Is
Yes,
carbonate 2 minus or 2 plus?
Which one? 2 valency, sorry, minus 2, minus 2. Okay. Now one more. You learned last year sulfate, sulfite, sulfide. When you see IDE, you should immediately identify it as non-metal whose name is ending with IDE. So sulfide is nothing but sulfur atom, correct? Sulfur 286. So sulfur has a tendency to lose 2 electron. So what ion it will form? S2 minus. This is nothing but what ion? Sulfide ion. There are 2 more radicals, which is sulfate and sulfite. Sulfate group is SO4 2 minus. What did I give you? One hint I gave you here. ATE and ITE should differ by what?
One
One.
oxygen atom.
One oxygen.
One oxygen. So sulfite will be SO3. Charge remains the same. So sulfate is SO4 2 minus. Sulfite is SO3 2 minus. You understood these two?
Yes, ma'am.
Now I'll go to valency minus 1. Why I'm teaching this is when I teach this and when I come here to valency minus 1, bisulfate, bisulfite, then it becomes easy. Okay. So bisulfate. Sulfate was what? SO4 having 2 negative charge. Bisulfate or hydrogen sulfate. H is H plus. So remove one positive and negative charge. So bisulfate is what? HSO4 minus. So similarly, bisulfite is nothing but HSO3 1 minus. Are you writing?
Yes, ma'am.
What happened? Something happened. Okay. Then you have learned last year aluminate permanganate. Correct. Aluminate is
Al2O3 minus.
ALO2 group. ALO2 group having a charge of 1 minus. This is called what? Aluminate. Permanganate. Like I think you have learned the compound potassium permanganate, KMNO4, correct?
KMNO4.
So permanganate is MNO4 group. This also has a charge of 1 minus. So aluminate is also an example of what? Valency of 1 minus. Permanganate is also an example for what? Valency of 1 minus. Okay, so valency -1, you have lot to study. Okay. Now valency -1, I'm still continuing below. Okay.
Ma'am, can you show the permanganate?
Yeah. Oh yeah. If you are writing, I'll wait. Should I make it small?
Done, ma'am.
Finished? Not able to go down. Why? Okay. Now, chlorine containing, let us learn, children. Okay. Last year you have learned just chloride. Correct? Yes or no?
Yes, ma'am.
Yes, ma'am.
Whatever I write, you write together now. Okay. See, chloride is nothing but just chlorine atom having a single negative charge. Correct? So, atomic number 17, electronic configuration 287. So, chlorine atom has a tendency to gain one electron. So, it forms an ion which is called chloride ion. Okay. But you have something called chlorate. Okay. Chlorite. One second. Chlorate. So chlorate is ClO3 group which has a charge of 1 minus. Now chlorite for ATE and ITE, what should I do? Remove one oxygen. Correct?
Yes, ma'am.
So ClO2 1 minus is chlorite. Okay. Then you have hypochlorite. For hypo, when you see the word hypo, you should remember, you should remove one more oxygen. Okay. Hypochlorite also, which is ClO1 minus. And for chlorate, there is a suffix per. Perchlorate. So for perchlorate, you should add one oxygen for chlorate. So ClO4 minus. So chlorate radical is ClO3 1 minus, chlorite ClO2 1 minus, hypochlorite just ClO minus, perchlorate add one oxygen for chlorate, ClO4 1 minus. Write this in the same fashion so it is easy for you to learn. Okay, for example, what is KClO3? KClO3 is nothing but potassium chlorate. Okay. Now what is KClO2? KClO2 compound is potassium chlorite. Can you see ClO2 1 minus? What is it? Chlorite. Now what is KClO? Look above and answer. Try to answer what is KClO. KClO is
Hypochlorite.
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 Potassium.
Potassium hypochlorite.
How you may feel what ma'am is teaching so much how to remember. It will just come by practice. Correct? I'm giving you in a way you should write so that when you study it becomes easy. So you also should practice, okay? Practice twice or thrice, then you will also become thorough. Okay. Then which is the other compound? What is KClO4? KClO4 1 minus. What is the ion called? Perchlorate. So this is potassium perchlorate. Please note down, I'll wait.
Ma'am, can you scroll a little up?
Yeah. Why is it not going?
Excuse me, ma'am. In some elements, you wrote like for example, ClO4 minus, whereas in the other element, the chlorate ClO3 1 minus.
This is only for chlorine containing. Okay, don't compare for sulfate, sulfite, and all.
Oh, okay.
Okay. So that is why that I finished together. Sulfide, sulfate. All three you together you learn. One more hint, children. One more trick. How will you remember? All chlorine containing. What inference did you draw from this? They have valency of -1. Like that you should remember. Understood? Everything has valency -1. Chloride, valency -1. Chlorate, valency -1. All these have valency of -1. Their sulfate, sulfite, sulfide. They all have valency of what? What valency did they show? See here, look here. What is the valency? Valency is
2 minus.
2 minus, -2. Okay, that is why I'm teaching whichever is common together. I'm teaching them so that when you learn together, it becomes easy for you also. Okay.
Okay, ma'am.
So in today's class, in detail, positive valency +1, negative valency -1, we have completed. Okay. So in the next class, we will start with divalent elements, +2, -2. Then we will proceed with +3, -3. Like that, we will continue. Please practice whatever the radicals and ions I have given today. You have to write and learn, write again and again so that you will remember. If chapter will become easy later.
Okay, ma'am.
Okay, children. Time is up now.
Ma'am, can you show
Can you just show the screen?
Ma'am, can you show the sulfur?
Okay. I'll show the screen. Don't
Thank you,
worry.
ma'am.
And below is it?
Ma'am, can you stop there?
From here?
Yes, ma'am.
Or should I still go down?
Ma'am, can you go a little down?
Go down.
Yeah.
Thank you, ma'am.
Bye, ma'am.
Okay, those who have finished writing, you leave, children.
Thank you, ma'am.
Thank you, ma'am.
Bye.